Here are some examples from the day 48 assignment where we're continuing to work with logarithms, but now we'll get into the properties of logarithms. Here they want us to express this as a single log and simplify if necessary round to the nearest thousandth. So here we have both base 9 logs, but the key is that we're adding them. When you're adding two separate logs, you can combine them under product property. So this would be the same thing as saying log base 9 of 12 times 60.75. We can go ahead and multiply 12 times 60.75, and that gives me 729. So I have log base 9 of 729. If that can be evaluated, you go ahead and do so. It looks like they do want us to round here. So since we're allowed to round, this looks like it can be done by a common base, but just to be safe, since we're allowed to round anyways, let's use change of base, which means that this is log 729 divided by log 9. We'll use our calculator. Divided by 9 log, and that gives me 3. So I know this is equal to 3. There was no need to round. Oops. All right, here write as a single logarithm, if necessary round. Well, this is already written as a single log, and yeah, technically we're going to be using exponent property. This is log base 14 of 14 to the 22nd. The logs cancel each other out, and because of power property, we can bring this 22 to the front. So this is just going to be 22. Log base 14 of 14 is 1. It cancels out, so 22 times 1 is just 22. All right, express this as a single log and simplify if necessary round. So here they want us to take log of log base 3, 27 minus log base 3 of 3, and they take that to the x power. So if I'm going to write this as a single log, the first thing I do is I use power property to bring the x to the front. Then I'm going to write the log. Now on the inside, I can actually use, because of the subtraction, I can use quotient property to say that this is going to be log 3 of 27 divided by 3, which is going to be x log log base 3 of 9. Now I can use, this is one that I could do in my head, but just to show you, since you're not that familiar with logs, you can just use change of base to say log 3 divided by log 9, and that's going to give you 2. So you get x log 2. Now it says to round, but because that log 2 is going to be irrational. Let me try putting in x log 2 first, and then if not, then I'll go ahead and round. X log 2. And see, they accepted it. Log 2 would have given me an irrational number, but that would have been kind of a weird way to write it. So they did end up accepting x log 2. That's the way I would have preferred it also. Okay, express this as a single log. So this says log base 2 of 5 plus log base 2 of 12 minus log base 2 of 3.75. The key here is that we have all the same base. So that's the first important thing, because if not, we wouldn't be able to write these as a single log. Now, we're going to be using two different properties. Because we're adding and subtracting, we're going to both use product property and quotient property, but I think it's actually easier to use these at the same time. So here's what I would advise you to do. It's going to be a single log, and it's going to be base 2. The logs that are positive, those go on top of a fraction. We're using quotient property, so there has to be a fraction. So that means that the 5 is going to go on top and the 12 is going to go on top, and those are going to be multiplied because that's product. And then the 3.75 goes on the bottom. So this is log base 2 of 60 divided by 3.75. This is not change of base. I haven't changed the base. I still have a log that's base 2. And 60 divided by 3.75, that gives me 16. So I have log base 2 of 16. Now that can be evaluated. I can even do that by common base if I wanted to, but most kids like to use change of base once they learn how to use it. So log 16 divided by log 2, that ends up giving me 4. So here we just end up with 4. Use common logs to solve this equation and then give the exact solution and its approximate solution, okay? So this says 8 to the power of 2x minus 4 minus 9 is equal to negative 2. So I want to reach the exponent, but I want to reach the variable, but that's up in the exponent. So let's see, I got to do plus 9 first. And now I have 2x minus 4. The key here, what I'm trying to do is isolate the base. Now that I have a single base and isolated, I can remove it by taking the log of the same base on both sides. So log base 8 on both sides. That's going to get this log to cancel, and I end up with 2x minus 4 is equal to log base 8 of 7. Now, because I'm trying to solve, I'm going to go ahead and use change of base. But the problem is when I use change of base here, I get an irrational number, and I don't want to round. So I'm going to leave this as log 7 divided by log 8. Feel free to put that in your calculator. It's just not going to give you a rational number. I will now go ahead and add 4 to both sides. So I get 2x is equal to log 7 over log 8 plus 4. And then with the final step, I'm supposed to divide by 2, but since I have a fraction on the other side, I'm going to choose to multiply by the reciprocal of 2, which is 1/2. Multiply everything on this side by 1/2. Let's pay close attention here, okay? When you distribute log 7 over log 8 times 1/2, well, anything times 1 is itself, so I keep the log 7 on top. But now the instinct of most children is to now say log 16. That is not the case. You cannot multiply a number that's where you're taking a log of it times a constant. So what happens to that 2? That 2 just goes out in front, and you say 2 log 8. Then the 4 also has to get distributed to the 1/2. 1/2 of 4 is 2. So for the first part where they want this written exact, which is on a test or quiz, that's where I don't really care too much about a decimal approximation. This is what I would be more likely to ask you for. You need to know how to write log 7 over 2 log 8, and then plus 2. Now we can worry about going to a calculator and rounding. Let's see, log 7 divided by 8 log times 2 close equals plus 2. I'm getting 2, they want it to 3 decimal places, so I'm getting 2.468. 2.468. If you mention something in class, I can help you with keying these into your calculator. It takes some practice. Finally, this is the last example here. Solve this equation for x and then round as well. So this says e to the 2x minus 5 over, well, I can't even tell what that says. That looks like a 5. I can't even tell on my screen. Oh, geez, I hope it's a 5. Equals 310, and solve for x. Well, the good thing here is that I have my base isolated, so I can already go ahead and remove it. I'm trying to get to the x, so the way you cancel out an e is with an ln. So I'm going to take ln on both sides. I cannot take the ln of 310 because that gives me an irrational number, so I'll leave that. So I get 2x minus 5 over 5, if that indeed is a 5, equals ln of 310. So we'll go times 5 on both sides. Do not multiply the 310 with the 5. You get 2x minus 5 is equal to 5 ln 310 plus 5 plus 5. So then I'll get 2x is equal to 5 ln of 310 plus 5. And then when we divide by 2 on both sides, hopefully they'll let us leave it like this as 5 ln 310 plus 5 over 2, because none of those can be divided by 2. So let's see, fraction 5 ln 310 plus 5 over 2, and then rounded 310 ln times 5 equals plus 5 equals divided by 2 equals 16.841. 16.841. Check your algebra. I got that part right. I can't see if that's... Let me try to see on a different screen if I can see it better. That wasn't a 5, it was a 3. So that's what I have to change. That was a 3 on the bottom. I couldn't see it right. That stays. So it was over 3 multiplied by 3, multiplied by 3, multiplied by 3. So the only thing that changes is I have a 3 in front here instead of a 5. So let's try changing that. (310 ln times 3 equals plus 5 equals divided by 2 equals). I'm getting 11.105. 11.105.